Gracias.
I believe I sit here? No.
Hello, 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 Wasm.io. So, success. We've sat in the right order. Anyway, look, welcome to our panel, Wasm Warriors, conquering real-world problems in production. Now, I'm super excited about this panel, not just because of the topic. I am excited about WebAssembly in production, but I'm super excited about the panel here. We've got a really great set of people. So, if we just do introductions first, then we'll get on to the questions. If we start at the end with Bailey.
Hello, everyone. My name is Bailey Hayes. I am one of the WASI co-chairs. That is the subgroup within the WebAssembly's community group. In the W3C, I am also on the technical steering committee of the Bytecode Alliance Foundation. And lastly, CTO at Cosmonic, which is a managed platform for CNCF Wasm Cloud.
Hello, this is Daniel Caballero. I'm embedded SRE in Fastly's Execute-D team. Execute-D is the core component of Fastly Compute, which is about running Wasm sessions for our customers in our platform. So happy to be here to share some stories. Thank you.
Hey folks, my name is Oscar Spencer. I am a principal engineer at F5 NGINX and co-author of the Grain programming language.
Hey everyone, so my name is Saúl Cabrera. I'm a staff developer at Shopify, where I work in the Shopify functions team, where we do a bunch of WebAssembly, so happy to be here and chat.
Good, cool. So, two things real quick, okay? I think it's fair to say the people that I'm sat here on the stage with are fantastic people, okay? So if you come across them in the halls here at Wasm.io, or if you're watching on the stream or later on at YouTube, we've put some social media handles up on the screen, just in case you want to approach them and ask them questions about this particular topic afterwards. I can't promise you'll always get a super quick response because we're all super busy and not always monitoring the socials, but I do know a great set of very humble people here who are keen to share their experiences, and I feel like also keen to learn experiences from yourselves as well about deploying WebAssembly into production. Now, we're on a clock, okay? So we're going to get straight into the questions, but we're going to kind of take you on a little bit of a journey, okay? And the idea is that you are an engineer, and you are, or you could be a little higher up than an engineer, you know, in management or something, but you're considering, should we be deploying WebAssembly to production in our environments? So we've tried to take the kind of questions that would come into your mind, like, I think we'll start out with, is now the right time for WebAssembly? Then we'll get onto some implementation specifics that you might have to consider. But then after that, we'll share some, I think, pretty cool stories as well. So I think the first question really is, and I don't mind who takes this one first, but is now a good time to be deploying WebAssembly into a live production environment? And if you want to take the question, please just offer for the mic.
Yeah, I can
Sure.
speak some more about that. So I would say it's always a good time for WebAssembly. At Shopify, we've been using it since a very, very long time now. It has been in production for a couple of years now without any serious issues. So I think WebAssembly is delivering in some key aspects of a production system, mainly safety and performance. So all that to say, I think it's also important to mention that it depends on what use case you want it for. It might be ready for some, but still missing in some aspects for others. So that's also something to take into account. But at least in our experience, it has been great.
Okay.
Yeah, from my point of view, well, Fastly released compute like more than 4 years ago. So yeah, I think there is like the answer is clear. And we are already like serving thousands of customer services. It's millions of requests per second. And if I think about potential alternatives for our use cases and other technologies, I actually cannot think about a better option than this. So yeah, I don't see an alternative. And the answer is yes.
So I think just with your two answers so far, okay, and feel free to chime in on this, I feel like potentially Shopify and Fastly are bleeding edge companies with an appetite for risk. like based on the level of engineers and things that you have within your organization. I don't know if anybody has anything, so I think Bailey would like the mic. I'm thinking more around if you're not a bleeding edge company. Those are great examples, but like for mere mortals, if I can say, like for the rest of us, do you have any thoughts?
The earliest that I started working with WebAssembly was in 2015 during the early design versions. And we deployed into production, I want to say, starting in 2016 behind a feature flag, and then the MVP of WebAssembly was available in 2017. So it's been around for some years. So not necessarily bleeding edge, and I was at one of those companies that maybe has been around since the 70s. I'm not going to say the name now because I don't want to disparage my old employer, but the use case was running data visualization applications inside the web. So we took about 2 million lines of C++ code, compiled that to WebAssembly, and then we were able to portably run it in many different use cases. And it was actually the core library, the core graphing library that many of our different solutions for this old school ISV provided, which was, I think, really fantastic.
Okay, so I think a takeaway there then is from all three of you so far, it's not necessarily as bleeding edge as we might think, and all three so far have said it's a good time to deploy to production. Oscar, do you have any opinions?
Yes, so I probably should have mentioned this during my intro of myself, but previously, before Nginx, I was the director of engineering at Suborbital, which was one of the Wasm startups. And one of the huge things that we noticed with WebAssembly was, hey, if you have legacy applications that have just been around forever, WebAssembly is a fantastic way to bring in new functionality to that application without disturbing it from its, eternal slumber or whatever you will, right? And so, on top of that as well, when you think about the production grade of WebAssembly code, really, WebAssembly at the end of the day is a compiler target, right? And so as long as we feel confident that it's stable and can run that code, that's never really the issue. You shouldn't feel bad that you're running WebAssembly in production. That's going to work. The question is, are the tool chains ready? Yeah. Are my teams ready to be able to take on WebAssembly as we're still building out all the tooling?
And I feel like the one on the question of teams is very individual per organization and sometimes per team within an organization as well. Like if your developers are keen to take on something new, where the tool chain may be a little bit nascent, that's maybe been a bit harsh, but if you've got that appetite, then it is a good time, yeah? Do you know, so I liked your point there about WebAssembly as a compilation target. So let's assume that within our organization we've decided, yeah, now is the right time to think about WebAssembly. One of the first questions that at least I would think is, okay, WebAssembly is a compilation target and it's supported by a bunch of languages, more languages going forward, but what kind of impact does that have on me now today to say, okay, we are going to go WebAssembly. What do I need to think about when it comes to language choice, and is that important?
Oh, it's incredibly important. I'd say the number one thing you want to do as a company saying, hey, we're going to take on WebAssembly, you got to pick your poison. More than any other language ecosystem, Rust is ready to go for you to actually start using WebAssembly for real. If you really feel like, hey, I want to dig into the weeds and get it working in different language ecosystems, you totally can. Everything is there and available for you to get it working, and we need those contributions from the community to come in and improve all the tooling. But it's absolutely important. Again, the actual WebAssembly artifacts, that doesn't matter. At Suborbital, we didn't care. As long as it was a WASM file and it ran, you could run it on the platform. That's no issue. But in terms of getting customers or getting stakeholders to provide those WASMs to you, you need to make sure that they're equipped to be able to do that. And so you should choose a language or language ecosystem that's able to get you where you want to go. Mm-hmm.
Yeah, from the Fastly perspective, given we are in the end a cloud provider, and we see different customers using different languages in our platform, what the angle that it's interesting is also how different languages are consuming resources in production, and how different they can behave from a latency perspective, memory usage. Even, for instance, Fastly supports currently Go, Rust, and JavaScript directly. Of course, anything else that can compile can be onboarded, but we can limit like the options. We need to limit the options. And yeah, and even in Golang, you can choose TinyGo or the standard Go compiler, and they produce binaries with different properties. So that is, I think, a point that every team needs to consider.
Yeah, I do want to emphasize, though, that we've had WebAssembly as a target for a good while now. So as far as targeting it, it's fairly straightforward if it's your code. You can pick, I think it's about 17 out of the top 20 languages. But to Oscar's point, there are gradients of support for the entire ecosystem to have great WebAssembly support. And so what that effectively looks like when you're doing this yourself to develop, you're pulling in dependencies from other open source libraries, third-party dependencies. The thing that often got me when I was working on C++, which was C and C++ were obviously one of the first to WebAssembly, we would run into issues where I was trying to pull in a library and it used something like pthread. There are solutions to work around it, and we can dig into that more if we want to, but I think effectively it's not just your code. That part's pretty easy, honestly. It's that next step of bringing your entire ecosystem along, and now is basically the best time for you, if you want to help contribute to your favorite project, please add a WebAssembly target to it.
Can I just ask then, if we pass the mic along to Saul, while that's coming along, are we on a journey towards a future where there's equal support across languages for WebAssembly? Do we think that's somewhere that we're, and I'm really here just asking for a nod of the head or a shake of the head. Will we get to a point where it matters less? Yeah? So I think, okay, that's a yes. Cool. Saul?
Yeah, so one thing that I wanted to emphasize is that you can create, you have a common basic common building block when it comes to WebAssembly. So you have multiple languages that can target it, but then as a platform, you work on top of WebAssembly to, to bring your features and to make sure that developers can do what your platform is supposed to do. And then the other important thing is that by having this common building block, you can actually have more control over what those programs should or should not be doing, which I think is very key. One good example, for example, is instruction counting. You can now say, well, I know that this is going to be compiled to WebAssembly. I can very accurately and deterministically say, this program should only execute X amount of instructions, and it's very granular if you want it to be that way.
Super. So I think that leads on to potentially a similar question. Certainly if you're new to the WebAssembly space, when you look at runtimes, it's not like the early days of Docker and containers where there was effectively one choice. There's loads of choice. So do we need to be thinking about which runtimes we're using and where we're using those?
I think the subject of runtimes is an interesting one, but at least from our perspective, there are several characteristics that we look into a runtime when we say we want to execute some WebAssembly code. And I think the main one of the main selling points of WebAssembly is security. And I think that one needs to be emphasized a lot because, the sandbox exists, but it's only as safe as the implementation. So looking at things like how well the engine is being fuzzed and, what security characteristics the resulting machine code contains, if it's a compiled implementation of the engine. I think those are crucial in order to say, I know that whatever is running in this engine is actually safe.
Sure. Daniel looks like he wants to say something.
Yes, I think our case at Fastly with the runtime, it's something that we made public like a long time ago. We started with our own implementation, Lucet, which got open sourced, and with some properties and functionality that was very specific to our use case, to distributing edge applications. But eventually, yeah, we joined forces with other companies, including Mozilla in the Bytecode Alliance, and that let us port our specific functionality to Wasm time, which for us has been working perfectly for our use case. For instance, the main functionality we need is ahead of time compilation, so we can execute applications millions of times, but compiling only once, and that makes a complete difference for us.
Super. So I think next question, if we just move it along, WebAssembly and Kubernetes. It's difficult to have a conversation or a discussion here about deploying to production without bringing Kubernetes in at some point, because it's fair to say a lot of organizations, love it or hate it, have Kubernetes and would be curious as to whether or not it is a good platform to run WebAssembly workloads. Bailey.
Absolutely. We've been running workloads in Kubernetes for a good while now. And when you think about WebAssembly as, your portable compilation target, it's really just compute. In Kubernetes, right now, your typical thing is a container is your unit of distribute. But if you're running WebAssembly on Kubernetes, your unit of distribute is actually your .wasm, your one WebAssembly module or component. And when you have an application architecture that understands how to run it, something that is perhaps a WebAssembly runtime, either running in a container or using many of the different approaches that I've seen crop up now. Some are better for running serverless-style applications. Others are better for long-running types of workloads, like any other kind of compute, because you're using Kubernetes to abstract your infrastructure, and it does a great job at that. When it comes down to it, so long as you have something that understands how to orchestrate your type of compute workload, you're going to have great success running on Kubernetes.
Anybody want to say anything further on that? Yeah.
Yes, just to complement also your point, I like it a lot, yesterday talks about mind the gap. And what it's really true is that most of the cloud computation today runs in Kubernetes. So I think that putting despite the final and ideal runtime maybe does not need to especially incorporate Kubernetes, the fact that you are making that possible makes a lot of sense.
So can I just ask on that, and then we'll move on. So are we saying that maybe Kubernetes is a good enough platform to schedule WebAssembly-based workloads on, but we might get more out of WebAssembly in certain other use cases on other platforms? Tell you what I'm thinking, and tell me if I'm wrong here, we overuse it, but the 80% rule. Would Kubernetes as a platform get decent enough performance and decent enough returns from WebAssembly, but we could consider other platforms if we want to get the maximum out of WebAssembly? Yeah.
I would say that if you're already using Kubernetes to abstract your infrastructure, it is your 100% awesome use case for it. There is absolutely no reason that WebAssembly doesn't run excellent on Kubernetes. It runs there just as well as anywhere else. But the anywhere else part is what's so freaking cool about WebAssembly. And I don't want anybody to have the takeaway that you're restricted there, because I could write one component and run it in my browser, on my Android phone, in Kubernetes at massive scale. I can basically run it anywhere. And to me, that's the most compelling thing, because I can finally hit the tenets that we used to hear from Java of write once, run anywhere. And it's not just run anywhere, it's running anywhere on any platform that understands this bytecode. And the ways that the platforms are now able to secure it, provide it with capabilities, and basically scale it out is a level of reliability that we've never been able to have before.
Okay, so do you want to say something?
No, but just the future is probably hybrid, so that also connects very well with the idea that in the end, your applications may need to interact with other things, with other infrastructure, with applications in other places, and despite Kubernetes is solving some problems that maybe Wasm doesn't have, it's, in any case, there will be applications there. There might be many customers with platforms there, so makes sense to put them, to being able to run this as well.
Brilliant. I think Kubernetes leads us on to maybe the next kind of question you might have as an organization, is if you are starting to implement things like platform engineering, what kind of impact does WebAssembly have on that? Oh, go on, Bailey.
I'd love to answer that one. Thank you. Yeah, I think that WebAssembly is a platform engineer's dream come true. I had a little detour after I did the kind of data visualization, web browser, more compilery route. I got to have some experience working on platform engineering, doing the lift and shift from our bare metal services into Kubernetes and into the cloud. And the entire time I ran into a couple different problems, which is this friction and tension between the engineers that want to build on my platform. They want me to provide things like authentication, authorization, lots of different types of middleware, common pieces that they can go through. And we've come up with a term called a golden path in platform engineering. The problem is that all of that is usually so tightly coupled, either to your language or framework choice. And then the second aspect there is if you decide to use a technique like a sidecar container, you typically have a much larger footprint. It's more expensive to run, and it's more complex, and maybe a little bit opaque to your developers. And you maybe not have as much direct control over their golden template, basically the piece that they would use to skeleton out their application. And so the reason why I feel that WebAssembly is basically a platform engineer's dream is that it's wildly deterministic, like Saul said earlier. So I know exactly how much it needs to run. I know exactly the types of resource limits I need to limit to this thing. I can even throttle it by instruction, right, with this technique called gas. But this other aspect that I think is really exciting, and I'm going to use a term that Luke Wagner came up with called SDKs for free. Basically, that means if I write a component in one language, the language that's best for my team and best for the problem that I'm trying to solve, and then all of my developers now can build on those exact same components, that authentication, authorization, middleware, but they're able to build in any other language that works best for their use case. And then all of a sudden, you've created a ubiquitous platform that is the only golden path that you need to make available, but it is ubiquitous. It's across all of these different languages and frameworks. And I think that's going to be just an exponential growth over the next year or two.
Cool. So I've got to, are you going to say something? Or, yeah.
Yeah, just to underscore that a little bit, one of the things that's beautiful about WebAssembly that we ran into at Suborbital was the fact that, yeah, you can run the stuff anywhere. So in our use cases, we said, hey, we want to run the Wasm modules bare metal, run them on ARM, so save a bunch of money, it's super fast, get all the performance out of that. But then at the end of the day, we had customers that said, nah, I want to deploy this on-prem. And it's like, that's cool, that's fine, we don't care. We don't even care what architecture your machines are. It's not a problem. That's never been a concern. And being able to engineer, not worrying about challenges like this is absolutely phenomenal.
Cool. So while you've got the mic, Oscar, I've actually got a question for you. So at Nginx, okay, so let's say I'm an organization, I've got a bunch of engineers. When you get WebAssembly embedded into an application such as Nginx, what kind of things do I need to think about and solve for there?
Yeah, that's definitely going to depend on your exact application. So I want to say 95% plus of applications you embed WebAssembly in, you probably don't need to worry too much at all. Just pick whatever your favorite runtime is. It's got bindings, whatever, run it. In the case of something like Nginx, and you've got so many different proxy choices, you've seen a bunch of different proxies implementing some sort of Wasm plugin system, and of course this is something we're exploring at Nginx. Thing about Nginx is something like 30% of internet traffic runs through Nginx. You break Nginx, you break the internet. So. Yeah. It's been a lot of deep conversations about a bunch of specifics of, hey, how can we actually integrate this in Nginx in a way that we're not going to break it? One of the things that folks have talked about earlier in the event so far is, hey, Preview 2 doesn't have streams yet. And that's kind of a big deal when you're implementing something like a proxy, where it's like, hey, actually, most of the time, doing the copies from one component to another is not really a big deal, but in the case of Nginx, where you're dealing with tons and tons of traffic, it actually is kind of a big deal to have to wait for the entire request to come in, so we're already waiting on there, then copy the entire request context into the Wasm memory so that way it's available there, and then continue. So we have to think about all sorts of things like this. If you think about, hey, actually I have 10,000 concurrent connections and they're all running multiple Wasm plugins, well, WebAssembly modules, Wasm memory is going to be at least one Wasm page, and that's 64K. So it says, okay, am I going to allocate memory, like 64K of memory for 3 plugins on every request times 10,000 requests? Like, is that something that I'm gonna do? Which the obvious answer to that is, oh, we probably can't do that. So you got to have, smarter techniques to, think about things like that, or even thinking about things like the event loop and things like WASI. Like Nginx has its own event loop, but let's say we're trying to use something like Wasm time, which the WASI implementation is going to be using like Tokyo, right? That's cool. That's not our event loop, right? And so you have to think through, is that WASI implementation okay for me? And if it's not okay for me, well, guess what? It's an interface. We can go write a full WASI implementation if we want to. So it's really gonna depend on your exact use case of your application. Most of the time, you probably don't have to care, but sometimes you can go super deep and think through a lot of these interesting problems. But hopefully people aren't having to deal with that sort of low level of detail.
Tell you what I can't get past, we're talking about production, 30% of the internet traffic going through Nginx. That's some pressure right there, yeah.
Yeah.
Cool.
It's like, I don't want to be that guy.
No, of course not. I think Daniel wants to say something.
Yeah, because a bit of this story sounds familiar to me. In our team, given we need to support like Wasm for many different customers and use cases, one of the key challenges and like day-to-day problems is like protecting the host resources from all these customer sessions that can do anything. So investing in our use case, for instance, we also need to invest a lot in protecting how much memory a given session can use, how much CPU, if there is host calls, maybe we need to protect and avoid one customer like consuming all open connections, for instance. So that's a very interesting part of the challenge.
Great. Can we move the mic along to Saul, please? I've got a question for you, Saul, because I know at Shopify you've got WebAssembly in production at some super cool scale, okay? We've got like about 3 minutes left. If you can take just a couple of minutes to run us through the cool stuff you do.
Yeah, so the main use case that we have for WebAssembly at Shopify is Shopify Functions, which is basically extending Shopify's backend. So if you are a third-party developer that wants to extend a piece of Shopify, like create custom discounts that Shopify doesn't know about out of the box, you write a function, you deploy that function, and then we run it when someone goes through a checkout that it's eligible for that execution to happen, and then you get a discount that it's very custom to a particular commerce rules. So that's like the main gist. We have multiple APIs to extend multiple pieces of Shopify. And then one question that we really get is like, how many functions do you have? What's the scale that you have reached? And I think we haven't really talked openly about this, but I think this could be a good opportunity. So one of the most awaited events, commerce events, is the Big Friday, Cyber Monday, when multiple sales happen. So that's when Shopify scale, we can actually see it. So for last year, we were able to reach a good number in terms of function invocations. So we were able to reach around 2.3 million just function invocations, not requests, just function invocations. That was, what we observed per minute during those 4 days where we are basically selling a bunch of things.
That's pretty sick. It feels like a mic drop moment. That's really good. I like it. So we've got about a minute or so left. And before we wrap, I'm happy to take a question or two from the audience, if you have any. But if you do, we've got one down at the front and one here. Please just do wait for our mic runners. We may only get one. We'll see. See if we get the evil eyes from somebody telling us to walk. Just speak. I'll repeat it if it doesn't come on.
Okay. Question goes to Oscar. So you were like talking a bit about the security aspect of using a runtime in Nginx, and like the internet depends on Nginx, right? As I understood it, you use your own process for the runtime. This is then executing the WebAssembly, right? Would you feel comfortable in like using the runtime in the same process as the main core Nginx for like performance benefits to like not have inter-process communication going? Or what would be the necessary steps for you to feel like, yeah, we can actually ship it to our own production in Nginx in the same process?
Yeah, this is something we're actively evaluating because it's tough, because you want to make sure it's like, this is something that we can't get wrong, right? So it depends, right? So we have the sandbox isolation. We can feel reasonably confident that with some of the runtimes, it's like, hey, the security guarantees are formally verified, so that's great. So we can be happy and know that at least the code running in WebAssembly isn't going to leak out and absolutely ruin something. But then you have the runtime itself, and you have to say, hey, is the runtime gonna be fine? Like, don't know. And that's tough. I mean, at least we have some things like, okay, well, this runtime is written in Rust, and so we know, okay, there's some like memory safety there, and that makes us feel a little bit better. We can go ahead and run it in another process, but then, yeah, that communication sucks, especially when you're trying to have the least amount of overhead possible. So I don't have a concrete answer for you because we're still looking into it, but there's a lot of really smart people, way smarter than me, who keep grilling me on questions of exactly this sort of stuff. But hopefully we'll be able to post some really cool blog posts about what we did when it's all said and done.
Super.
Thanks.
Do we have time for another one? Is somebody going to give me a... Let's take one more and then come and kick us off the stage. If we can be as quick as we can getting the mic across. This guy down here at the front. Keep it short.
I'll try. So one of the most exciting things for me, and probably the reason why I'm here, I'll talk quickly, is the component model. It's the biggest advancement that I've seen in terms of like leaps and bounds recently. My question, I'll try and make it semi-specific, is how does that specification, how do you feel that specification affects how you run WebAssembly at the moment? Because for me, it takes it from a compilation target onto application architecture, which is like huge. Yeah. So how does that move affect what you're doing in production at the moment, and what do you see it enabling in future as that itself moves towards a production release?
Is the one person feels they can tackle that quickly? Daniel's keen.
I can provide like a very specific, fastly answer. One is today we have multiple teams, like for instance, creating specific components to provide fastly specific functionality to compute. This is going to completely change the way they are shipping these services rather than requiring host calls and inter-process communication. Customers will be able to bring that functionality close to their services. Plus, today, for instance, there are many customers also using like what we call service chaining. So they have multiple deployments with different applications, and they call over the network, one to the other. That is going to bring also like a massive performance improvement, given everything will run in the same service.
Super. I'm going to call it at that. Just to draw everybody's attention, though, you can speak to any of them in the hallway as well. I'm sure they're super approachable. We've got, if you're on the live stream or watching on YouTube, we've got everybody's social media handles as well. Feel free to reach out. Just to summarize, I think the answers are yes, WebAssembly is ready for production. It's important at the moment to choose the right language. It's important at the moment to choose the right runtime. Kubernetes isn't the worst place in the world for WebAssembly. And go and enjoy the rest of the conference. But can we get a huge round of applause for our panelists, please? Let's go.